Okay, this is the second problem that we were discussing in class, and in this case, we're going to remove these loads, 400 and 600 newtons, and replace them by weights due to the members of the truss. So the free body diagram that we'll end up with is something like this, where you have loads at each joint. And the question is, what are these FC, FD, FB, and so on? Well, let's see how we do that. First, we need to find the weight of each member. So this member here, let's say F for BC, for instance, for member BC, the mass is 5 kilograms per meters times 2. So the mass is 10 kilograms. So therefore the weight is 5 kilograms per meters times 2 meters times 9.81 meters per second square. So this is the weight, right? And that divided by 2. So that is the weight that comes on that we're going to put that we're going to add at C due to this member. For this one here, then we get 5 kilograms per meters times the length of this guy, which is square root of 2 meters, right? That is square root of 2 meters times 9.81 meters per second square times 1/2. So that gives me what? That gives me that this is equal to 5 kilograms meters times 9.81 meters per second square divided by what? Well, I have a 2 divided by 2 plus square root of 2 divided by 2. So that is FC. Okay, what is FD? Well, FD then would be the weight due to this guy. So it's going to be 5 kilograms meters times 9.81 meters per second, right? So this one here is going to contribute with 1 square root of 2 over 2. This one here is going to contribute with another square root of 2 over 2. And this one here, the top one, is going to contribute with 1, 2 plus 2 over 2. So then we can write, in this way, we can write all the weights. So let's just write them down. I'm going to erase this and write them down so we have a space. And so basically FC would be equal to FA, and that is equal to 5 times 9.81, 2 over 2 plus square root of 2 over 2, and that is equal to 83.7 newtons. Then FB, so these are the weights at these 2 points here. FB is equal to what? I'm going to have 1/2 coming from this. So this is equal to 5 times 9.81. Then I have 2 over 2 coming from here plus 2 over 2 coming from this one plus square root of 2 over 2 plus square root of 2 over 2 coming from these two members. And that gave me what? That gave me 167.4 newtons. Now we have this and this and this, so we need to find one of these. So FD is equal to FE, which is equal to 5 times 9.81. And then I get what? I get 2 over 2, okay, 2 over 2 plus square root of 2 over 2 plus square root of 2 over 2. Okay, so that is this is the loads that we are going to have. And now from here, we can go ahead and start solving our problem using the joints. And this is very simple. First, we need to find the the normal force here. So we're going to have a normal force here coming from A, that's Cy, right? And let's draw that in blue. This is Cy coming here. And so Cy, for that, we start with the moments about A. The moments about A are what? The moments about A are Cy times 4, and then the moments due to each one of these, and then you get plus minus, sorry, this all FD times 3 plus FB times 2 plus FE times 1, and that is equal to 0. And I can solve for that now, and I get that Cy is equal to 285.8 newtons. Okay, so then now I can find the forces on this joint. And if I find these two forces on this member, I'm already done with this because of symmetry, right? So basically, I only need to do this and this guy, these two joints, and then I'll be done. So let's start with C, joint C, and then for that, I get in the x-axis. Well, let's draw the free body diagram first. Always have to draw free body diagrams. So we get FC, then we get here FCD, then we get the normal force CY, and then we get FCV, right? So now I can write the equations. I can write CY minus FC minus FCD cosine of 45 degrees, that's equal to 0. And then FCV minus FCD sine of 45 degree, that's equal to 0. And then I can go ahead and solve for this. And then I get that FCD is equal to 285 newtons, and then FCV is equal to 202 newtons. Okay, and you have to realize that now I know these two forces on these two members, and I also know the forces on these two members because they are the same. By the way, this one is in compression, this is compression, and this is tension. Okay, so now I know I know this member, this member, this member, and this member. So I only need this member and this member. So if I work on this joint B here and this joint D, sorry, here, then I'm done. So let's draw a free body diagram for D. A free body diagram for D would be, you get the load here, FD, then you get FDE, the force coming from this member, then you get here you get FCD, and here you get FDB. And now we can write the equations. We can go ahead and write the equations, and then that's it. That means that FCD cosine of 45 degrees minus FD minus FDB sine of 45 degrees, that's equal to 0. And then FDE minus F dV sine of 45 degrees. And sine of cosine in this case are the same. Actually, this should be cosine, but sine of 45 is the same as cosine of 45. And let's just fix it just to make sure. Uh, Cosine of 45 degrees plus FCD cosine of 45 degree, and that is equal to 0. And now I can solve for that, and I can get that F dV is equal to 180 newtons, and that's a tension, and FDE is equal to 286 newtons, and that's compression. And of course, the other forces are the same by symmetry, and this is the problem.